Change notes. This is following our competition for boiling the hottest water and freezing the coldest water, chilling the water coldest. So what we found in the boiling water challenge is that you can't change the temperature of boiling water. So let's find out why. So let's start out at negative 10 degrees. Now I'm working with water, and that's important because only water are going to follow these temperatures. But I take a block of ice out of a deep freeze at negative 10 degrees and I sit it on the counter. And it's going to warm up. And the kinetic energy of the particles is going to increase as the temperature increases, because temperature really is a reflection of kinetic energy. Now it's going to warm up to a point, but then it's going to warm up to a point where it's no longer only a solid, because right here we have just a solid block of ice. It's going to warm up until it reaches 0 degrees, and then it is going to start to melt. So this 0 degrees here is my melting point. Here I'm melting, and as long as I have ice and water in my container, so this is solid and liquid, as long as I have ice in there, as long as I have the 2 phases, my temperature can't change. It's one thing or the other. It's either the temperature's changing or the phase is changing. So now my energy that's going in, and I'm pumping in thermal energy, it's on a hot plate. It is trying to warm up. The question is, where's the energy? Because it's not kinetic energy anymore. Kinetic energy is temperature. But what is happening here when it's just a solid, the particles are starting to move faster and faster. So I've got my particles all in a solid, and they're starting to move, but they're still staying in that solid. When I get to this point, now my solid particles are starting to lose that structure. They're starting to lose that crystal structure. And it takes potential energy to do that. My potential energy is going up. I'm not changing the kinetic energy. They're still moving just as fast as they were before, but now they're starting to break out of that crystal structure, and it takes energy to do that. Those particles like to be together in that solid, side by side, uptight. And so you have to put in energy to get them to move away. Now once I have only liquid, now my water can start to warm up. If I only have liquid in my cup, and if my temperature is changing, that means my kinetic energy is going up. These particles of liquid now are moving faster and faster. They're not, oh, I drew them way too far apart there, didn't I? Because particles of liquid are not that much farther apart than particles of solid. They just don't have that little crystal structure to them. 6, 7, 8, 9. My kinetic energy is increasing. These are starting to move faster and faster and faster, and they move faster and faster and faster until they reach, if they're water, 100 degrees Celsius. Then I don't have water alone in my beaker. Now I have liquid and gas. I have reached the boiling point. And at the boiling point now, again, I have a change of phase. Remember, we can do one thing. We can change the temperature or we can change the phase. So what's happening here is those water particles, they like to be together, but now we're giving them enough energy that they have the potential to turn to gas. So my potential energy is increasing. 1, 2, 3, 4, 5, 6, 7, 8, 9. They're going to keep moving faster, well, not faster and faster because it's not potential energy, but it really likes to be together. They really like each other. So it takes a lot of energy to kick them farther away from each other. And then once we have turned everything into a gas, then our kinetic energy can go back up again, and we can see a temperature change. If you have a choice between putting your hand in boiling water or putting your hand in steam, put your hand in the boiling water. It's going to be a less severe burn because gas has no limit on its temperature, but boiling water is limited to 100 degrees Celsius. Couple of terms. We call this a heating and cooling curve. That's the melting point there. This is the boiling point. And if I were taking heat out, it wouldn't be the boiling point, it would be the condensation point. If I were taking heat out, this would be the freezing point. It's just a matter of its energy in or energy out. I hope that helps a little bit. Have a good evening.